I am recording. So today's class extends the discussion that we've been having on matrices and their role in solving systems of equations. As I mentioned before, you're more than welcome to use technological tools to do this work. There's no reason not to use them. And I'll display, what I'm talking about on the TI-84 for those of you who have that. And I'll also be using the Symbolab matrix calculator, which is shared. The link to it is in our course. So I'm going to begin by sharing my browser and show you where we are in the course. Okay, we're currently in week 3, and we're in the second part of week 3. So what we're going to be talking about today is determinants and Cramer's rule. Okay, those are both two things related to matrices. Determinants have much larger uses in mathematics, especially in other linear algebra applications, say to do with statistics. Cramer's rule and determinants are also used when you do higher level calculus, things that would require you to, say, change variables in an integral. I know you don't know what that means necessarily, but just understand there are applications beyond what I'm showing you. And again, nowadays we can leverage some of the gross computation, the actual cranking through arithmetic. We can leverage that onto technology. So we will, okay? And again, I guess what I'm trying to say in too many words is you have other tools that you can use that would maybe not be as cumbersome as doing these things by hand. I'm just showing you how to do them by hand and with technology, so you have a better understanding of what's going on here. Okay, so I'm going to begin by opening these notes. So these are the notes I'm going to use, determinants and Cramer's rule. If you have them or you want to download them or open them on another tab, that'd be fine. It would be a good idea if you have your TI-84 handy to have that around, or to open the Symbolab calculator, the matrix calculator, on another tab. Okay, so let me just show you again where this stuff is. I'm going to slide on down to the end of the course, which is past the final exam. See, I'm down here by week 15. Okay, it's important to know where this stuff is online. Here's the final. Here are the complete textbooks that we're using in this course. Okay, we're not using all of the textbooks, but if you want to do a little more reading about a particular topic, here's where you would go. And then here's the online tools and calculators. All right, so here's Web 2.0, Scientific Calculator, Desmos, the fraction calculator. And I'm going to be using the Symbolab matrix calculator. And again, you can see some other related tools here that you can use for matrices. Okay, so I'm going to be using this and possibly the scientific calculator. So again, I want to make sure everybody can find things. Again, if you're ever not comfortable or you're thinking, what is she using now? Ask, okay, and I'll point you to it. All right, so right now, let me share my tablet with you. And that will take me a minute or so to get going. Okay, and let me share that content with you. All right, so everybody should be able to see determinants and Cramer's rule. Okay, I have the chat open, so if you have any comments or questions, either unmute yourself and just ask, or you can put them in the chat. Okay, so let's talk about determinants. Okay, what exactly is it? Okay, it's a value that's calculated from the elements in a matrix. Okay, and it's essentially a useful value because it can help you solve the system of equations. Now, again, it's a square matrix that we're calculating the determinant of, And there are a couple of notations for it, so I want you to be comfortable with that. One notation is DET with the matrix in parentheses, okay? Or there's this notation, which looks an awful lot like absolute value, okay? It's vertical bars, but the reason you know it's not absolute value is the value inside the vertical bars is a matrix, okay? It's not an algebraic expression or a number, okay? So again, there are a lot of symbols in mathematics, like vertical bars, like parentheses, that are kind of overused. And the way you tell what they mean is by looking at context. That means you look around and you see, all right, well, this is a matrix, so I know the vertical bars must mean determinant and not absolute value. Like with parentheses, if you're talking about intervals, you know the two values in parentheses are both, say, x values rather than an ordered pair, okay? It's kind of like any foreign language or any language you speak where sometimes the meaning of a word is different depending on how it's used in a sentence. So it's the same way in math, okay? So calculating the determinant, now we said it's a scalar value. For your purposes, just say this is not a matrix. Okay, not a matrix, but a number. Okay, so I'm talking about a number like 2 or -7. Okay, that's, for your purposes, a scalar is a non-matrix number. Okay, and the way you calculate it, it uses the diagonals on the matrix. So let's take a look at a simple case with a 2 by 2 matrix. Okay, so imagine we have numbers in the matrix A, B, C, D. Okay, and we've seen this sort of before in one of the previous lessons. The determinant of this matrix, okay, of A, B, C, D is just taken by multiplying across the diagonal going from left to right, and then subtracting the product of the diagonal going the other way, right? So essentially, you can look at it like this. First, you multiply this way, and then you multiply that way, okay? So it's AD minus BC. And again, it doesn't matter which order you do the multiply in, right? Because DA and AD are the same product. Same thing with BC and CB. Okay, so let's look at a real simple example. Okay, now we'll put some numbers in it. So I'm going to go down the diagonal this way first, and I'm going to have 1 times 4. And then I'm going to go this way up the diagonal, minus 3 times 2. Okay, or 2 times 3, whatever you want, however you want to write it. Okay, so this is 4 minus 6. So my determinant, okay, so determinant of A, which I could also write like this, is -2. Okay. So basically, let's have you try one. Let's build a matrix that is okay, there's a matrix. You see if you can find the determinant of B. Okay, so you try this. Okay, so type done when you finish. Okay, but again, just do the determinant calculation yourself. And again, you've got an example right above. Okay, we'll wait for a few more folks to get a value. Actually give it a try, folks. Okay, let's see if we can get one more person to be done before we work it. Okay. All right, so now I'm asking you another question in the chat. For those of you who responded, what did you get for a value? Okay, everybody who tried it is getting 14. Good for you. Okay, so again, let's do the diagonal business again. First, 3 times 6, right? And then the diagonal going the other way, minus -4 times -1. Okay, so that's 18 minus 4, which is 14. Okay, everybody comfortable with that? And yes, I know we have technology to help us do this. But again, I want to show you how it's done, because this might have implications later on if you find yourself in a stats class, not necessarily GBS 221, but other stats classes in the future. Now, this process gets more complicated the larger the matrix gets. So just, again, bear with me while I show you. Here's a 3 by 3 matrix. And again, we're finding determinants of square matrices. Okay. And we've labeled the elements A, B, C, D, E, F, G, H, I. Again, this is just to show you the pattern. Okay. So if you want to find the determinant of a 3 by 3 matrix, it says write all the elements of the original matrix Okay, so those are my original elements. And then it says copy columns 1 and 2 to the right of column 3. Okay, so if you take a look, I've got column 1, 2, and 3 here. 1, 2, and 3. And I'm going to copy the first two columns to the right of what's there. Okay, so I have A, B, G, B, E, H. Okay, and it says sum the products of the elements along the 3 diagonals going down. Okay, now that means from left to right. Okay, down from left to right. And again, another way to describe that is saying from northwest to southeast. Okay, if you're comfortable with points on a compass, okay, you've got north, east, south, west. So what we're doing is we're going from northwest to southeast, so that way. All right, so I'm going to circle those diagonals, okay? Here's one, here's another, here's a third. And again, I apologize for my messy handwriting. Okay, so basically they're A, E, I. That's the first diagonal. B, F, G. That's the second diagonal. And C, E, H. These are the diagonals down. Okay. Now, again, I want those summed together. I'm going to put them in parentheses. And then I have to worry about the diagonals going up. I'm going to change my color. Okay, from southwest to northeast. That's this way. Okay, so this is also from left to right, up. All right, and on my picture over here, those are going to be GEC, HFA, and IBB. Okay, so I'm going to write those here. Okay, so those are the diagonals going from left to right, but going up. And if you wanted to actually find the determinant of that matrix, okay, and I'm trying to see, did I call it something? Yeah, I called it A. What would that be? That would be your going down diagonals, AEI plus BFG plus CDH minus your going up diagonals. So GEC, HFA plus IDB. Okay, so basically that's how you would actually compute it. You need these extra two columns over here, so you'll get diagonals of 3 elements each. Okay, so again, I promise we're going to do this by hand once. Okay, just once. Okay, so you can see how it works. All right, and I have to kind of pay attention to what I'm doing here. All right, so first I'm going to copy the first 2 columns over again. Okay, so 2, 8, 5, 4, 1, 7. Right? Then I have to do my diagonals down from left to right. Okay, so that would be 2 times 1 times 9. That's the first diagonal. Plus 4 times 3 times 5. That's the second diagonal. And the last one is 6 times 8 times 7. Okay, those are my upward diagonals. And again, this is something you can evaluate on any calculator. Okay, either your TI or the Web 2.0 calculator. Let me go there briefly just to show you that I can evaluate this on a calculator, show you how to do that. I'll put an equal sign, so have it. All right, so here's my Web 2.0 calculator, and that was 2 times 1 times 9 plus, and again, order of operations will take over here, and the multiplies will happen before the adds, which is what I want. And the last one is 6 times 8 times 7. So those are my downward diagonals, and that gives me a total of 414. So I'll write that here. Okay, so up, oh, these are down rather, down. And now I have to worry about the diagonals going up from left to right. Okay, so again, look at how I did them up here. The first one is going to be 516, then 732, and 984. Put them right under. Oops. Okay, and then I do the same thing. I would just go to my favorite calculator, okay, which could be the TI. I'm going to bring the TI up over here and share that with you. Okay, and let's turn it on. And that would be 5 times 1 times 6 plus 7 times 3 times 2 plus 9 times 8 times 4 equals. So that gives me 360. Okay, and basically the pattern for determinant of A is down minus up, right? I guess I should switch to a black pen here. Okay, which is 414 minus 360. And again, in this case, that's real quick. Okay, and you might be wondering, so great, what's 54? It's kind of like, you know, the answer to the universe and everything is 42. I mean, what good is it? Essentially, it's telling you about the internal structure of your matrix. Okay, and it's kind of all rolled up into one number. Okay, and it's useful. It's useful in a lot of ways. And I'm just going to show you a few of those ways where the determinant is useful. Okay, but let me stop here and ask any questions so far. Any questions so far? Anybody? Just give me a shout out, yes or no. Have we got questions? All right. Okay. What I'd like to do before we get into the uses of a determinant is I'd like to show you how to calculate a determinant with both the TI and with the Symbolab matrix calculator. So I'm going to go back to our simple matrix because I'm lazy and I don't want to type in the 3x3 matrix. Okay, so essentially, let's take a look at this original one I had here. Okay, which was 1, 2, 3, 4. And we got a determinant of -2, right? So let's try that one. I'm going to bring up the TI first, right? And I'm going to go into my matrix menu. Second inverse is my matrix menu. I'm going to put in my 2x2 matrix into matrix A. Okay, so that was 1, 2, 3, 4. Okay, I'm going to quit out of here so I don't mess up my matrix, right? And then I'm going to go back in the matrix menu to math. And you can see determinant, det is our first choice. So I'm going to select that. And then I just put the name of the matrix in here. So go back to matrix, to the names menu, select the name of your matrix. And I should get -2, which I do. Okay. So that's how you do it on the TI. You store your matrix in one of your matrices, go to the math menu, determinant is the very first choice. Okay. So let's see it on Symbolab. So I need to minimize my notes so you can see Symbolab. This is the Symbolab matrix calculator. And again, remember how this works. You get to pick the size first. If you don't see the size you want here, you go to this array and you basically highlight the size like this. Okay, so I can get a custom size matrix here, or I can take one of the predetermined sizes here. So let me put in my numbers. Okay, and I think I can just say det, and I should get the determinant. And you can see here's the determinant down here, -2. Okay, so Symbolab's a little bit different from the TI, namely whatever option you're trying to do, like inverse or determinant, you kind of put it in front of the name of the matrix. Okay. Operations are pretty straightforward. You just use the operation symbol that you're interested in, multiply or add or subtract. Okay. So questions on using the calculators. Questions on using either calculator? Are we good? Instead of copying 2 columns, I copied the 2 rows. Okay. Basically, the strategy is, copy the columns to get the determinant, or better yet, just use one of these features. Okay. So I'm asking you is don't compute the determinants by hand. I just showed you how it's done by hand. But this is a perfectly valid tool to use. So for example, I'll leave determinant there and I'll put 3 by 3, and I can enter the 3 by 3 matrix that we used, which was 2, 4, 6, 8, 1, 3. This is the one from the notes where we had a determinant of 54. Oops, wrong one. 8, 1, 3, and then 5, 7, 9. Okay, so I guess what I'm saying is if you're going to do it by hand, follow the process I gave you, or you won't get the right determinant. But don't bother doing it by hand because you have a tool. Okay, so this, I'm just double checking. I didn't make any entry mistakes. This was the one we just did by hand. Okay, and we got a determinant of 54. So let's just see that this gives me a determinant of 54. Okay, so see it right here. Okay, so basically my advice is use one of the calculators to figure or calculate a determinant. Okay, use one of the calculators. It's too error prone to do it yourself. I mean, it's not hard, it's tedious. Okay, it's kind of like messing up an entry in accounting. Okay, then you've got to go back and figure out where the mistake was. Okay, so not necessarily hard, but tedious. So use the tools, they're here. Okay, okay. So hopefully I answered that question. Okay, I guess my answer to the question is if you copy the rows, you're not getting the right determinant. Okay. All right. So let's go back and let's focus more on, so great, now I know how to do this, or I have a tool that can do it for me. What good is it? Okay. It's yet another way to solve systems of equations. Part of the reason for showing you this is to give you an understanding of the concepts behind solving systems with matrices. Okay, it's great that we have tools to use it, but you kind of want to know the calculating that goes on behind the scenes. So you're better positioned like later on to use the right tool for the right problem. Usually there's more than one way to solve a problem, but there are usually one easy way or one best way to do it. And the only way you get to that point is through a lot of practice. Again, like I said, math is a historical discipline, just like anything else, okay? And different people were working on matrices around the same time, and they all came up with different ways to do things. And we're talking about, the 18th century, there were no calculators. So everything had to be worked out by hand. And in doing so, mathematicians determined the deep structural relationships between all of these numbers in a matrix. Okay, and that's kind of the underpinning of what's behind your TI-84 or your Symbolab calculator. Okay. All righty, and understanding how something works inside can also, it provides a very valuable benefit to you. Namely, you can look at the results of something and you can say, no, I don't think that's right because I know how it's done. If you don't have that ability, then you're stuck with looking at the output of a calculator or a computer and saying, I don't know, the computer came up with the answer, I guess it's right. In reality, the computer may have been programmed wrong. I'm not talking about a TI calculator or an app that's on a website, but if you're in a business situation and you're looking at computer output, don't always make the assumption that the output's correct. Okay, it's important to understand how the calculation was done. In other words, understand the guts of it. Okay, and I'm speaking to you as a former computer programmer. Right, and I've seen my share of errors. Okay, so anyway, let's take a look at what you can use the determinant for if you're solving a system of equations with a matrix. Okay, so here's the determinant, okay, that we're building. See the determinant down here? Okay, if you have this matrix A and you want to determine its inverse, you need the determinant. So in other words, this can be written as 1 over the determinant of A times D, negative B, negative C, A. All right, so this little thing under here is the determinant of A. Okay, you can see it there. All right, it's also used in Cramer's rule, which is useful when you only need one solution of a system of equations. Okay, and you might say, why would I only want one solution? Well, suppose you have a system of equations and it's solved for all of the variables, say 3, 4, 5, whatever, and you want to tweak it to change one of them. Okay, you only really want to solve for that one variable. You don't want to go through the whole thing all over again. Okay, I realize with computers and technology, it's pretty quick to just resolve everything. Okay, but back in the day, okay, you pretty much didn't want to have to go through all the hand calculating. So you would just have a way to solve for one of the variables. Okay. So again, determinants also capture things like, you remember transformations from college algebra where you take a function and you either translate it or you shrink it or stretch it. Basically, determinants can help you figure out how transformations can change the variables in a matrix. And what might those be connected to? They might be connected to the volume of a solid, okay, or an integral that you're trying to calculate the value of. So if you make transformations to it, this determinant, because it relates to the structure of how these things are related to each other, can give you an insight on how those things are changing, okay? And again, I realize that as business majors, you might not ever see that, or you might see it and it'll be embedded in software, okay? It might not be obvious to you that it's math. Okay? So again, let's move on, okay, to Cramer's rule. And again, this says to Google it and find out information. I'll save you the trouble. We'll talk about it together. Okay, so Cramer's rule is, what is it used for? Okay, so basically it uses determinants to solve a system for one variable. One variable. That's the basic use of it. Okay, without having to calculate all of them again. Okay. So let's look at some like a process, a cookbook recipe. Let's call the determinant of the coefficient matrix. I'll abbreviate determinant as DET. Okay, so I'm going to have a system and I'm going to have a coefficient matrix. Okay, so the determinant of that is going to be D. Okay, normally it's a square matrix. Why is that? Well, for a system of equations, typically you have as many equations as you have variables. And in a coefficient matrix, the rows are the equations and the columns are the variables. So you'll have the same number of each. Okay? Then let's call D sub x the determinant of the coefficient matrix with the x column replaced by the constant matrix. Okay, so okay, with the X column replaced by the constants. That's the stuff that's on the right-hand side of the equal sign. Okay, let's call d sub y. Okay, so let's say we have a 3 by 3 coefficient matrix, and I'm going to call my variables x, y, and z. You could call them x1, x2, x3. You could call them, you know, Tom, Dick, and Harry. It doesn't matter what you call them, okay, as long as you're consistent. Okay, so d sub y is the determinant of the coefficient matrix with the x column, the y column rather, replaced by the constants. Okay, and lastly, we're going to call d sub z the determinant of the coefficient matrix with the z column replaced by the constants. And again, the process generalizes if you have fewer equations and variables, and if you have more equations and variables, okay? So I found an example where we can use Cramer's rule. So does everybody pretty much understand what I'm talking about here? We're going to start with a square coefficient matrix, and then we're going to create matrices X, Y, and Z, where you start with the coefficient matrix and you replace the columns one at a time by the right-hand sides. Okay, so is this description clear before we launch into an example? Okay, can everybody get a mental picture of what we're going to be doing? Imagine a square matrix, and then one by one, we're going to take out the first column, replace it with the right-hand side. Then we're going to take out the second column, replace it with the right-hand side, and lastly, the third column. Okay. So here's a system that I found. Okay, and it's 3 equations and 3 unknowns, which will give us a square coefficient matrix. Okay, so everybody comfortable with this? Okay. So the first thing I'm going to do, according to Cramer's rule, is I'm going to build D, I'm going to build the coefficient matrix. Okay, so let's call A the coefficient matrix. All right, and I'm going to look at my variables, and I'm just going to pull off the coefficients. Okay, coefficients only. And then the last one. Okay, is everybody comfortable with that as the coefficient matrix? Okay. And I'm going to also build, again, you can see the right-hand side. Let's call it R, the right-hand side. That's 3, 0, 0. Okay, everybody comfortable with that? Is the right-hand side? Okay. So the first thing I want is the determinant, D, is the determinant of A, right? The coefficient matrix. And again, I'm not going to calculate it by hand. Okay, I'm going to take this matrix over to my Symbolab matrix calculator and figure out its determinant. Okay, and I'm going to show you how easy it is with this matrix calculator to just go in and change one row at a time. Okay, so I prefer the Symbolab matrix calculator for a Cramer's rule problem. Okay, so I'm going to go over there and I'm going to figure out the determinant of matrix A. Okay, so let me erase this one and put in another 3 by 3. Okay, and that's 2, 1, 1. Make sure that 1, negative 1, negative 1. Oops. And 1, 2, 1. Okay, so there's my coefficient matrix that I copied out of my system of equations. And now I just want the determinant of it. This will be my D value. And I get 3 for the determinant. See it right here? Again, I'm looking just for number. So I'm going to go over here back to my notes, and I'm going to write determinant of A is 3. Okay, then I have to build all of my coefficient matrices with the different rows, the different columns substituted, okay? So I'm going to build another matrix, B, okay? And remember how I have to do this. I have to start with A, but I need to replace this column with this, okay? So again, replace the X column. This is my X column, my Y column, my Z column, because it corresponds to the different variables in the equations. So this is going to be 3, 0, 0. And then just copy everything else from your coefficient matrix. Okay, so don't mess with the other two columns. Okay, so there's my B matrix. Okay, and to find D sub X, that's going to be the determinant of B. Okay, everybody good with that? All right, so I'm going to go back to my Symbolab matrix calculator. I'm just going to type over my first row, my first column rather, with 3, 0, 0. Okay, and find the determinant of that. That's going to be D sub X. Okay, and you can see that also gave me a 3. Okay, everybody see D sub X here? Okay. So go back over here and that's 3. Okay. Next, I'm going to build a matrix C to handle Y. Okay, and then what I'm going to do is, whoops, rather than replace the first column, I'm going to replace the second column with my constants. Okay, so make sure you copy the first column as it is, replace the second column with your constants, and copy the third column as it is. So there's your C matrix. And your D sub Y is going to be determinant of C. Okay, so again, I'm going to go back to Symbolab. I'll have to retype in my first column because I trashed it the first time. So 2 and 1. All right, so there's my coefficient matrix. And I'm going to replace the middle column with the 3, 3, 0, 0. All right, and find the determinant of that. And that gave me a negative 6. Okay, so this is D sub Y, the determinant of the Y coefficients. Okay, So I'm going to go back here and put in -6. Okay. And the last thing I need to do is to find the Z ones. Again, I'm not going to use D. I've already used D for something. So E is going to be the coefficient matrix, but with the last Z column replaced. So I'm going to copy the first two. And then replace the last column with my constants. Okay, and you can see in every case I've replaced one of the columns with the constants. So now I want D sub Z, which is going to be the determinant of this matrix. Okay, so again, back to Symbolab, replace this middle column with 1, -1, and 2, and I'm back to my coefficient matrix. And then this last column gets replaced with the right-hand side's constants, and find the determinant of that. And that gives me a 9. Okay, so this is D sub Z, which gives me a 9. Okay, now the last step of Cramer's rule, okay, which I didn't put up here, it says that X is equal to D sub X over D, Y is equal to D sub Y over D, and Z is equal to D sub Z over D. Okay, so basically, if you just wanted to solve for one of the variables, all you need to find is the determinant of the coefficients, and the determinant of the coefficients with that column replaced with the constants. So it would be real easy to just solve for one variable. You wouldn't need to do all of this. Okay? So let's take a look at what that would be. X is dx over d. Well, according to my work over here, dx is 3, and d is also 3, which means x is 1. Okay, y is dy over d. Okay, my dy value was -6. My d value is 3, which means y is -2. And z is dz over d, which is 9 over 3. So my z value is 3. Okay, so here is your solution to the system. And again, if you just needed to recalculate one of these, the only thing you'd have to recalculate, let's say I wanted to recalculate x, the only thing I'd have to figure out would be, if the right-hand sides change, I'd have to figure out dx, d sub x, and recalculate. Okay, so again, it'd be easy if I change my right-hand sides. Okay, I just need to calculate one of these submatrices. I don't need to go through the whole thing again. Okay, so anybody got questions on the process? Questions on Cramer's rule process? Anybody? Okay. What? Okay, no. Just let's wait and see if anybody has anything. Let me ask you this. Could I solve this system with rref? System. What do you think? In other words, I'm asking you, do I have to use Cramer's rule? Okay, Anna is saying yeah. Anybody else have a thought? Okay. It's important to understand when and why you can use a certain strategy. Okay, that's like the most important thing, because again, there's tools to do the heavy lifting. Okay, any system like this can probably be solved with RF. We got an actual unique solution, so we should get the same unique solution. You can use, Zainab is saying, can I use a matrix inverse? Yes, you can solve this system any one of three ways, well, four ways that you know about. Okay, you can put it in a matrix, an augmented matrix, and solve it with RF. You can put it in a coefficient matrix, a variable matrix, a right-hand side matrix, and use a matrix inverse, right? You could do A inverse times B. You can also use Cramer's rule like we just did. And the other way, if you're old school, you can solve it algebraically. Okay? Which way is easiest? Which way is easiest? In other words, if you came across this problem, this system, and it said, solve the system, and it didn't tell you how to do it, or a teacher wasn't saying, I want to see you do Cramer's rule. You're in the real world, in the wild, and you have to solve it. How would you solve it? Which way is easiest? Anybody have any thoughts? There's no wrong answer here. It's your opinion. Okay. Well, I'm talking about this system right here in number 3. Okay, if you came across this and you wanted to know what's X, Y, and Z, how would you solve it? Personally, I think RF is the easiest. Okay, I got one matrix to type in. I don't need to find inverses, I don't need to find determinants, and I don't need to do algebra. Okay, so let's go to Symbolab and let's explore this a little. Okay, so I'm going to get rid of this. We did the Cramer's rule thing. So one suggestion was take the inverse of the coefficient matrix and multiply it by the constant matrix, right? So inverse of 2, 1, 1, 1, negative 1, negative 1. Make sure I don't screw up the coefficients. And then 1, 2, 1. Okay? So here's our coefficient matrix. We're going to invert it, and we're going to multiply it by the right-hand sides. Remember, that's what we did last time. We used matrix inverse to solve the system. Okay, so my right-hand side is a 3 by 1. Don't see it, so I'm going to make it. Okay, and that's 3, 0, 0. Okay, so this is A inverse times B. And again, you see the values I should get. Something is not right. I wonder if I need a multiply in here. Didn't get the same values. Let me just double check that I have the right coefficients. 2, 1, 1, 2, 1. Let me force a multiply. Not sure why it's behaving like that. You may have an order of operations problem. Again, I should be getting 1, negative 2, 3. I think I'm doing something wrong here in Symbolab, but I'm not sure what it is. Okay. I'll get back to you on that one. Okay. So let's try the RF. Okay, that requires an augmented matrix. So that would be 2, 1, 1. And then the right-hand side is a 3. And then 1, negative 1, negative 1. And the right-hand side's a 0. And then 1, 2, 1. Oops. 1, 2, 1. And the right-hand side's a 0. Okay, so this would be using RF in Symbolab. So let's go here and see that we get some values. And again, it's not behaving the way I expect. Solving. Oh, here it is. Here's the solution. You got to scroll down sometimes because it's wordy. Here are the solutions in reduced row echelon form. So 1, negative 2, 3. Okay. So using RF in Symbolab, where you just put in an augmented matrix, and what is that? It's the coefficients, and the last column is your right-hand sides. And then just hit go, okay? And that means solve it. And then make sure you scroll down to where you see the words reduced row echelon form. And here are your X, your Y, and your Z, okay? I have to do a little more research to see why using the matrix inverse didn't behave the way I wanted here, okay? I should have been able to do inverse of A times the constants and get the same solution. But it might have to do with the way I'm typing it in. Okay, so I'll do a little bit of work on that and I'll get back to you, I promise. Okay? Anybody questions? But the idea is, yes, there are multiple ways to do it. And they're all probably equally applicable, but there is one problem with using Cramer's rule. Okay? Can anybody imagine what would be wrong? Okay? What could go wrong with Cramer's rule? Anybody have any ideas? So again, why do I like RF? Because RF sort of always works. Remember, with matrix inverses, sometimes I can't find an inverse. Remember we talked about singular matrices? And it's related to the determinant. And that's also the same problem with Cramer's rule. Okay, this won't work on a singular matrix. Okay, that is one where the determinant of A is equal to 0. So when you do the subtraction of the diagonals, everything zeroes out. Okay, why is that a problem? Because you're dividing by determinants and you can't divide by 0. Okay, and that's the same reason, okay, because you're using a determinant when you find an inverse, okay, at least if you calculate the inverse rather than actually using row operations to create it, okay, you have the same problem. Okay, if you've got a singular matrix, you're not going to be able to create an inverse. Okay, so RF will work all the time. So I'm giving you a piece of advice. If you can, use RF. Okay, build an augmented matrix and try to solve that. Okay, are the limitations clear? Okay, are the limitations clear? I want to make sure everybody understands when to use what. Yeah? Okay. Yeah. And again, I'll figure out what I'm doing wrong in Symbolab with inverses. Okay. Here's one last thing. Okay. Let's take a look again at a U try. Okay. So I'm going to open up a piece of regular paper, and this will be the last thing we work on. Okay. So all I want you to do is U try Okay, start with this system. Okay, so here's a system of equations. And what I need you to do is to build the coefficient matrix. Yeah. A, then find D, which equals the determinant of A. Okay, then build using the information from Cramer's rule, also build the matrices for X, Y, and Z. Okay, and then find D sub X, D sub Y, D sub Z. Okay, so you don't necessarily need to go all the way to a solution. Okay, I'm deliberately not asking you to find a solution so you don't short circuit the process and use something else. I want to see that you can walk your way through Cramer's rule. Okay, so I'm going to say, let's spend a couple of minutes on this. Okay, so let's see if you can try the problem on the whiteboard and type done when you finish. Okay, so you're finding determinant of A, so find big D, then D sub X, D sub Y, D sub Z. Those are the things you're finding. Okay, so find these four determinants. And then type done when you finish. Okay, find these four determinants. I'll highlight them just so you know what I'm talking about. What four determinants? These. Okay. Let me know if you get stuck. Okay, folks, I know not everybody's done, but a couple of you are done. Let's just come together so we're all on the same page, so to speak. Okay, I've started putting up some scaffolding here for you. So again, let's just take a look at this to make sure we're all starting out correctly. Here's our system, and here's the coefficient matrix where I'm just pulling the coefficients off the left-hand sides and putting them in a matrix. So I have my X column, my Y column, my Z column. This is the right-hand side. I think I called that matrix R the last time. Okay, and that's got the 4, 1, and 5 in it. Okay, so this would be your A matrix. Okay, then I said build the matrices for X, Y, and Z. Okay, so remember how that works. You're going to take the coefficient matrix and replace the column of interest with your right-hand side. So here's my X matrix. It's the same as the coefficient matrix, except the first column is replaced with the right-hand side. Okay, my Y matrix is the same as the coefficient matrix, but the Y column is replaced with the right-hand side. And the Z matrix is the coefficient matrix with the last column replaced with the right-hand side. So if you are still building your matrices, please take a look at these and make sure that your matrices are correct. Okay, so make sure you did the replacement with the coefficients correctly. Okay. Now what I'm going to do is I give you a moment to look at that. I'm going to try to slide this over, and I'm going to briefly minimize the chat. Okay, so if you have a problem with anything you're seeing on the screen, please just unmute yourself and ask, okay, because I don't have the chat up. Because I'm going to bring up the TI-84 and show you what it's like to do this on the TI-84. Okay, so I'm turning it on. I'm going to go into my memory management delete and just get rid of the matrices I have there. So memory management delete, matrix is 5, and just delete the one that's in there. Okay, then I can go into my matrix edit menu, and I need to create 4 3x3 matrices. Okay, I'm going to call them A, B, C, and E. Okay, so the first one is A, it's a 3x3, and this is just going to be my coefficient matrix. Stop. Okay, so there's my coefficient matrix. Okay, and that looks correct. Quit. Go back into my matrix menu, go over to edit, go down to B. That's also going to be a 3x3. And that's going to be this matrix right here, the 4, 5, 4. One, 4, 3, 5. And again, I need to use the correct leading negative sign here. So here's my B matrix. Quit out of that, go back into matrix, edit, matrix C, also a 3x3, and that's going to be this matrix here. So 2, 4, 4, 1, 1, 3, 1, 5, and -2. Okay, and then the last one I'm going to enter in is E. Okay, and that's number 5. That's also a 3x3. And that's 2, 5, 4, 1, 4, 1, and 1, 3. And no negative numbers in that one. Okay, so I have all my matrices in the calculator, and now I'm going to go into my matrix menu over to math and find all the determinants. So first I need the determinant of A, my coefficient matrix. Okay, and that's a -1. Okay, so I'm going to write that down somewhere. Okay, you could conceivably store these in variables on your calculator. Okay, so I could store determinant of A in a variable called D. Okay, and then I could store all these other determinants in other variables. Okay, the variables aren't very mnemonic, so that can be as tedious as just writing them down on a piece of paper. Okay, so here's my coefficient matrix determinant. I wrote that down. And then I'm going to do basically the determinant for my second matrix. So determinant of B. Okay, and that gives me a -3. So underneath here, I'm going to write D sub x equals determinant of B, which is -3. Okay, and then I'm going to do it for C. And select matrix C. And that gives me a 2. That's D sub y equals determinant of C, which equals +2. And the last one is going to be matrix E. Okay. And that gave me a 10. Okay, somehow or other, I think I screwed up that matrix E. Let me go in there and look at matrix E. Okay. Is everybody else getting these determinants, or am I making some typos? Okay, so let me ask. I'll bring up the chat. Are you getting these values? Okay, so are you getting these values? Anybody have anything to say? Please unmute or chat. Are you getting the same values? Okay, so when I worked it out before, my determinant for A is right. Okay, -3 working. That looks good. I'm questioning my matrix E. Is that correct? I didn't get 10. Okay, let me go back and look at matrix E. So second matrix. Let's go to edit land and let's look at matrix E. So it should be 254, 241, 135. Did I do this correctly? Okay, so this is my right-hand side, 415. Okay, 254 is correct. I'm just checking my two first columns. Ah, see the problem? The problem's the negative sign here. Okay, I lost my negative sign on my 3. Okay, so I'm going to arrow through the matrix. And replace my +3 with my -3. Okay, so here was my problem. This was supposed to be a negative. Okay. So quit out of here, and let's try that determinant E again. Okay, how's -2 for determinant of E? Is that better? Okay, yeah, okay, good. All right, so it's real easy to fat finger things, and losing negative signs is a real good way to do that. Okay, so just I happened to look at these before, work them out, okay, and I noticed, hey, I didn't get the same answer for E. Okay, matrices, just like spreadsheets, are very error prone. Okay, so it's worth to go back and check your numbers. All right, so now if I want to find my variables, x is going to be d sub x over d, which is -3 over -1. So x equals 3. Okay, my y value is going to be d sub y over d, which is 2 over -1. So y is -2. And last but not least, z is d sub z over d, -2 over -1. So z equals +2. For those of you who got all the way through the problem, do you agree with my answers? Did anybody get anything different? If I haven't said it already, I'll say it again. If you see me making a mistake, please call it out. All right? That's what you're going to have to do in your career. If you're collaborating with a bunch of people on something that's, even if it's not math oriented, but let's say it is, there's no answer key. The only way you're going to determine if what you're doing is correct is if everybody has eyes on it and everybody calls out what they see. Okay, so that's welcome. All right. So anybody questions on determinants or Cramer's rule? Anybody got questions? Coming back to the meeting? Questions, anybody on anything we covered today?